Hi, in today's video, what we're going to be talking about is what is a linear function? Linear functions are, after all, the first chapter in our course, and it's often the first type of function described when exploring the theory of functions. So we should just start by understanding what exactly it is that we're talking about. So the first thing I would like to communicate here is we don't want to sort of be too abstract or reinvent the wheel. Just think of the title or the name of this object. The linear function is a function that's describable as a line or looks like it could represent a line in Cartesian space. So what we notice about lines in general, if I draw a couple of them here, if I draw out some lines, what we see about them is that they all have some sort of constant rate of change, even if that rate of change, say, is zero. So if I look at this this line here, every time I go to the right by some units, I'm also going up by some units as well. Over here, every time I'm going right by some units, I'm going down by some units. Here, the same thing happens, but it's shallower than before. But nevertheless, every time I shift over, I'm going up, or in this case, or yeah, up by the same amount no matter where I am. And here on a horizontal line, I am changing by the same amount no matter when I move right. It just so happens that that change is zero. So maybe the best way to define a linear function is to say a linear function is a function with a constant rate of change. All right. And so to sort of illustrate this, I wrote out some sample examples of partial descriptions of functions. And what I want us to sort of ask ourselves for a moment is which one of these represents or looks like they could represent a linear function or could come from a linear function. So if we take a look at our first function, we notice that, hey, my x values I was going up by 1 each time, right? So every time x goes up by, so in each step here, x goes up by 1, then 1, then 1, then 1. And if I look at my output values, or usually generally represented by the variable y, we see, hey, every time x goes up by 1, y goes up by 2, y goes up by 2 again, y goes up by 2 again, y goes up by 2 again. All right. And so this, at least this description of a function, looks like it could represent a linear function. But if we take a look at this second example, I still have plus ones everywhere on the top, right? Every time uh, I go forward, my x value goes up by 1. But look at what happens to my y values. First, they decrease by 3, and then they decrease by 1, and then they go up by 1, and then they go up by 3. So that rate of change is not constant, right? Every time I go up to the right by 1, my x values increases by 1. My y value increases or decreases depending on what the x value is. And the amount that it increases or decreases by also changes. So none of that's any good for a linear function, right? Our linear function, we want that to have a constant rate of change, and what we see here is that that's not constant. Alright, so this is purely from an arithmetic or algebraic point of view. Let's see how this corresponds geometrically. So over here I have our points plotted. Let's get rid of this for now. If I'm just looking at the table 0, 3, 1, 5, 2, 7, just like we had before, we see these points lining up in a row like this, and that does look like they belong to a line, right? Now, if I go over to the second set of points that I have laid out, we see that it goes down and then it goes down and then up and up. It does look like this function is curving a little bit, right? It doesn't look like these points come from a straight line. Now, if I go ahead and put in graph this function here, and for right now we won't worry about how we got that function, but if I plot that we see that this is a line, right, with these points on it, and that these points in fact align with being on a line. Whereas if I plot these points with this function, we can see that they align with this curve here, which is not a straight line. So in the example we just laid out, f of x, which is represented here at the top, is a linear function, or looks like it could come from a linear function, and g of x down here certainly cannot be represented by a linear function. Alright, thank you very much. If you have any questions, please let me know. Thank you.